Vishnavani, am I audible to you? Let me talk her offline itself. So in the meantime, I want to convey this message to you all again that whenever the task will be given to you, maybe of Linux or so or anything, you on the same day need to communicate if you will be facing any sort of issue on that day. Don't wait for the next day to get connected to me. Also, you are being given the names of the person who can solve your queries, who can assist you up by presenting over there physically in the office.
Like sir, command was successful. Like if we were able to understand what IP table is or what it does,
Mhm.
but we were not sure like what should we configure, because there should some be like there should be some use case, right? So like we listed IP tables, we read all the ports, those were open, and what inbound and outbound permissions are there, but we were not able to like know that what to a new rule to add or what a new rule to deny in that.
Yeah, basically, let us take an example over here. We have 22 number port SSH normally enabled over here in our machines. So if we don't want any other external person to ping or to connect to our SSH port, we can always block our 22 SSH port, may it be outwards or inbound. There are two type of connection, inbound and outbound connection. Okay. So we can always create a rule in IP table itself to block port number 22 on my own machine IP address. So this is the use case, simple use case to block any of inbound or outbound connection. Okay, like if I am serving any website itself, maybe on port number 80, and I am getting DDoS attack continuously on port number 80 for denial of service. I can always, for the certain point in time, block port number 80 by using firewall rules till I can solve the problem of DDoS attack. Until unless I don't block port number 80, it will be heavily consuming by port number 80, and in turn, it will break my internal system down. It will take all the processing power of my internal system. So that particular Linux system or any server will go into deadlock sort of situation where all the resources, memory, and all will be hogged up. So to simply avoid that situation, we can block that port so that no external threat will be problematic for the system or will be creating some sort of problem until and unless we can solve that particular situation. These are the basic use cases. Okay. So, one my humble request to you all again, start communicating with the people who are over there in Bangalore itself. Just start basic communication with them. When you will be acclimatized to those persons, you will be friendly to those persons, then you will not basically be hesitant enough to talk your problems to them. So just be acclimatized with them, talk to them, and then in any case when doing any sort of task, if you want any help, you can always reach out to them and solve the problems itself. I believe most of you today have not completed the tasks of yesterday, and the document itself are not ready. So no issues. Just take my advice for today. Will be any other problem you are having in the yesterday's tasks or so, you can always put those things to me, or in offline after the session itself, you can reach out to the respective team members, Linux or any. Okay, let us start today's session without wasting any other time. My screen is visible.
So
So yesterday itself, I had written over there in the chat box itself that we will be today moving towards or will be gaining basic knowledge of Kafka. So to start with, basically, yesterday we are having a discussion around data engineering. What data engineering is, what is ETL, what is extract, transform, and load, what are the various other uh, terminologies basically. What's there are around this data engineering. So we started with ETL. We started with what source are, what destinations are, what is transformation. So this all we had gone through the yesterday's session itself. Now, the most important thing what we read about yesterday was Spark. How Spark do the transformations. What is structured, semi-structured, as well as unstructured data. You know, all understand this terminology, semi-structured, structured, unstructured sort of datas. You know,
Yes, sir.
okay. Now, I expect you should have gained the knowledge that what was the use case of data engineering, why we need to transfer big data from one location to another, what are the various sources of big data. May it be bigger databases which are operating on hardware, means transactional databases. We need to migrate those to the data warehouses for analytics or business intelligence purposes. This is one of the use case of ETL, where we need to transform the data as per our business needs to analyze it. We had a story around this in yesterday's session, that why business intelligence people need the old historic data to have their decisions about business clear and prompt. Okay, so they basically normally use the old historic data, and ETLs and pipelines comes into play to transfer those huge data from one location to another or from one structure to another. May it be from row-oriented database to column-oriented database. May it be from a actual database to a data warehouse, or may it be from any source to data lake house. This sort of terminologies were used in yesterday's sessions, and the reason behind the data transfer was very much clear. Now, yesterday, because of time's sake, we had left one of the use cases over here, which is very prominent, and that particular use case is of IoT devices and web searches. Likewise, YouTube or any other social networking application, those websites, or you can say the the websites what log our data for future reference purposes. So let us take an example of YouTube itself. When on YouTube you surf some videos, you stumble upon some videos, you view some videos, you always have seen that the view count increases, and that view count don't increases instantly, but after some point in time, that view count add up. After you have liked some videos, that particular thing goes instantly in like status. But view count is something different over here. And what you have already observed that if you are viewing some sort of videos on YouTube, may it be some cartoons or so, or may it be the videos related to some technology, let it be Kafka or some other advanced technology or so, you will be getting suggestions for new videos in your profile. You get the suggestions as per your previous viewing history. Is this true or not? You get the suggestions as per your previous viewing history now.
Yes, sir.
So have you ever thought of that how these all things happen? What is basic going behind the scenes? How the YouTube have billions of customers, and at any point in time, billions and billions of consumers are using the YouTube instantaneously. So what is the underlying architecture or infrastructure they have chosen so they can always do all these things flawlessly? They can always are giving suggestions. Their view count of individual videos is increasing without any fail. So how they are basically implementing all these things? Any idea on this much large scale, billions of queries at a time?
So like I have read some blogs where YouTube mentions that they treat their views as a currency because
Mhm.
they have this monetization and all everything. So for that they
Yes.
have built very redundant systems where view counter acts as transactions, like we
Mhm.
discussed yesterday. So
Mhm.
these all views that are gathering, and like
Mhm.
simultaneously we both can like also press click on the same video, so that
Mhm.
can lead to latency or anything that can break the system. But they have created this sort of queue wherever the
Yes. Q comes
milliseconds.
into action here. What
Yes.
Q is? Actual data structure named Q is the central point over here. And normally the larger websites and the redundant queues which are mature enough, they are being used. And one of that structure is Kafka. Ever heard of this name anywhere before?
Yes,
What
sir.
Kafka
We
is?
have to understand.
Streaming supports streaming, creates
Yes.
chunks of data.
Basically, yes. Basically, Kafka basically है ना, how Kafka works is it has a producer. Producer is what is generating data, from where data is coming, and it has consumer. Consumer is where data is being transferred or where data is being stored or for analytical purposes or for streaming purposes, where data is put up on that particular place or location is known as consumer. And actual Kafka is nothing but topics. Topics having various partitions. Multiple topics having various partitions. And these topics basically with various partitions are being hosted on a place which is called broker. So I'll come on to this in very simple manner if you want. Kafka is a cluster of cluster of virtual machines, or worse, whatsoever you can say, a cluster of machines. What processes the data, or what transfers the data from one place to another in a flawless manner by providing high availability, by providing fault tolerance. These are the basics in production system. Normally, whenever we are using any system inside a production environment, we require high availability, we require fault tolerance. So, in any point in time, if one hardware, physical hardware fails, or if one software component system fails, it has some sort of backup mechanism always what can take its job. Okay, this is what we call as high availability and fault tolerances. If fault occurs, so that must by itself can be tolerated inside the system. Such sort of things are being made into the cluster. So in distributed system, so Kafka is nothing, not only single machine for the bigger environments or production environments. Let us take an example. If YouTube is using Kafka, so it is not using a single machine to handheld those billions of data transactions at a time. So it is a cluster of thousands and thousands of machines running simultaneously, continuously, and how the architecture of those particular clusters is so that they can be highly available and they can be fault tolerant. Okay. So yesterday I have put this particular topic in the chat box itself because so I needed you to basically Google upon this thing and to get the basic knowledge of that so that for today's topic or session can be more fruitful to you. So Kafka have different you can say components. One is producer, another one is consumer. You know what producer is? Producer is what fetches, yeah, what gets the data. Okay, consumer is what is storing the data and some other place or for consumption itself. So how Kafka works is it has brokers and the actual data is being split up into topics. So now let us take all these things into a you can say example scenario. If YouTube is producer to Kafka, so Kafka is being connected to YouTube API interface. So YouTube will be constantly pushing the data into Kafka. So either it be YouTube web application used on browsers or YouTube mobile application made be on iOS or on Android operating system. The code of that front-end application does what? It takes the actions of the users, whatsoever it is taking, may be viewing the video, translates it into a log message or anything like JSON format or so, and then it will be pushing those particular logs or JSON semi-structured or unstructured data sort of thing or structured data onto some queue, or in this case, it is pushing the log having views that on what video the consumer has or the user has viewed the application, the video on application. So that name of that video along with the ID or whatsoever the basic structure of that log is, it is constantly pushing those particular logs or data onto a predetermined location or a API which is being consumed by Kafka. So they are pushing the data onto a Kafka system. So topics means may it be for views or any sort of data structure, they'll be having different topics. For you can say likes, they'll be having different topics. So all those things are being translated into various topics. So to manage the data flow, so that no similar sort of data can interfere with other sort of data. This is very pre-built structure in applications itself. They are pushing all the identifiable information onto the Kafka system also. They are pushing the data onto topics, and now topics will be consumed by, may it be some data warehouse, data lake, or any other storage which is being then integrated with any of the other application, may it be artificial intelligence a model which is consuming those data to create some information which should have been processed in a manner so that the actual um, knowledge can be extracted from that. So in this particular case, the knowledge is how many views for what video are there, and how those particular data are being translating into monetization or any other purpose. So internally, what is being happening is a system which is producer is constantly pushing the data onto a huge infrastructure. Kafka is nothing but a very huge infrastructure being spun upon some cloud service provider. This is what we call Kafka cluster. The Kafka cluster is a system that comprises of different brokers. Here, brokers are the actual machines what are processing the things. And those brokers are the topics and the respective partitions. We will not be going to those partitions because it will be more confusing to you. Let us take an example, a single use case for a single topic. Okay, and then data is written to the topic within the cluster. This is what basically actually a Kafka cluster is. So now what producers are? The producer sends or writes the data message onto the topic. So in this case, YouTube application or YouTube web app, which is responsible for sending or writing the data onto the topics corresponding to what data structure it is. Okay, so that huge amount of data can be stored onto some other data warehouse or lake, and this particular Kafka is responsible. Kafka is responsible that no single message can be dropped. Means we, in YouTube sense or in any other application sense, we can't afford a even single of the message to be dropped or to be not available or to be lost anywhere. So Kafka will take the responsibility that not even a single like will be dropped anywhere. Okay. It will not be lost anywhere. This is the case. Wait a second. Okay. So this is basically the reason we use fault tolerant and highly available system. So if because at a continuous amount and at a very faster pace, the data is being produced by the bigger applications, may it be YouTube or so. So it is always possible that few of the data can be lost somewhere because of latency, redundancy, or system which is consuming the thing is not available. Because of those, it can always happen. So Kafka is made in that fashion that it will be highly available. One of the topic will not be only be present in a single broker. It will be translated or replicated onto the multiple brokers, so that if at any point in time one broker is overloaded, his task can be undertook by the other brokers. Same thing is replicated onto the multiple places or physical hardware itself. And there is a term named zookeeper, which is keeping track of all the brokers, which is keeping track of all the physical hardware as well as brokers, which is keeping track of all the consumers, and which is keeping track of producers, so that the synchronization can be made. Means Zookeeper will continuously check that whether consumer is capable of ingesting that huge data in shortest possible amount of time, or there is latency. If there will be latency, it will ask the brokers, are you handling the data efficiently? Please wait a bit. Have the queue get a buffer. Means it will do what? It will increase number of brokers so that the data partitions inside the topics can be held for a certain amount of time, which is called latency, up till when consumer is not available to consume. So this will make sure that none of the data is lost anywhere. Understood how the actual things work, how the fault tolerance, high availability, and the you can say redundancy takes place in such systems.
Yes, sir.
Sir,
I believe, yeah.
yeah, sir.
Yes, sir.
Actually, like you said, that for the view and for the likes, they have separate services. And
Mhm.
so I wanted to know that is this like Kafka is following microservice architecture or the monolithic architecture?
See, the point over here is that Kafka is itself a server cluster. It is not a singleton application, we can say. Kafka is like a Spark server cluster. So Spark server cluster, as we have discussed yesterday itself, its main purpose was to transform the data by using different of the layers. Here, Kafka's main purpose is to flawlessly stream the data without any loss of data. So it is following an architecture. Architecture basically comprises of physical machines named brokers and the queues, singleton partitions, which are known as topics itself. So this is an architecture so that the data can flow flawlessly. And you are saying of microservices or monolithic application, here the actual components what are driving the topics or the packages what are being basically used to spin up the Kafka topics into a broker or Zookeeper itself, they are similar applications, or you can say replica of each other spun up upon different broker servers, and the management and the data, you can say metadata keeping. Metadata, is the purpose of, is the responsibility of Zookeeper, which is running on few other hardwares or which is running on different, you can say VM or so. So it is an architecture basically which is handling the data in a parallel manner. Okay, the term microservices or monolith comes into action when we are basically hosting some application over somewhere and that application is serving to some other person. So those applications basically will be, you can say, of form monolithic or microservices based application, and each of the microservice will have their individual, you can say, responsibility to cater. Means one of the microservices responsible for user. Here, this is not the case. Same topic when used by YouTube can be uh, can be configured to have the views. Same topic is used by some other application because Kafka is not only supporting the YouTube application only, it is supporting IoT devices which are streaming video data also. So the terminology is topic. So we can configure the topic as per our requirements. So we'll be giving that this particular topic is being created for YouTube producer and it will be having so and so and so constraints. So we configure it like that the first topic will have so constraint and that will translate into views itself. Maybe you understood what basically the terminology behind it is.
Yes, but
So actually Kafka is not a you can say microservice based serving application. It is an architecture which is being spun up upon multiple virtual machines. That is why we call it as cluster of servers. Okay. Perfect. Not to go very deep into this because these are advanced topics and advanced one. I was basically thinking of just to give you brief knowledge that how the things spin up over there in the real world. So my purpose was to introduce you to the Kafka. Kafka is nothing but a queue streaming queue. Where it is used for um, what I can say, exact use case, what I can say is tracking website activity. Tracking website activity means to track how many views are going on, to track what is going on onto the website, what various logs are being created by the website. If they are fast enough, they want to be stored onto some systems or some, you can say, databases, so that those logs can be used afterwards for actual data extraction of the client. We can see after storing the logs of the web activity, we can always generate a knowledge from that what sort of customer is that who was stumbling upon the website. So what are his preferences? What is his behavior? What he likes the most? So that after offline processing of that particular data, whatsoever log data is being stored onto Hadoop system or any big data systems, we can always translate it into the useful information what should be used to track the future you can say transactions of the client. We can predict that this particular client can be targeted to sell maybe TV. If he was searching for TV for a long time, it is most is the probability that he wants to purchase a TV. So you will be getting the ads of various of the TV sellers. This is what actually happens to you. Yes, Prakhar?
Kafka is just responsible for creating a database, a warehouse, or is it also uh, uh, a standalone application which we would say processes the data for? Ju-
There is another option which is Kafka streaming. So Kafka
Okay.
streaming is one. Kafka processing is also one of the. No, the main purpose of Kafka is very small, but very important here. Main purpose of Kafka is to transport the data without the data loss. Because in normal scenarios, the big websites with the billions of users, they are generating huge amount of data at any point in time. Every seconds, gigabytes of data logs are being created worldwide. If gigabytes and terabytes of such logs are being created worldwide, we must need a redundant, fault tolerant, and highly available system so that few GBs of those logs cannot get lost because of some server issue, because of latency issue, because of network issue. There will be a lot of issues. So to reduce this or to solve this very simple problem, we want a big architecture for big data.
Yes, sir.
Kafka is nothing but simply a overhyped queue. What
Okay.
consumes the data from one side and pushes the data onto the second side, and to basically nip the evil of lost data, we have created such a sort of bigger architecture so that we can have fault tolerance, we can have high availability without any data loss. So what I can say is Kafka does only one job. If I'll say this is YouTube, which is producer, I'll know just translate all the architecture into this simple pipe. Okay, say queue. Data for logs is going into this queue, and this queue is responsible. This is shielding the data loss. And in other side, may it be transporting the data to the Spark cluster. for Spark cluster for transformations. In the real fashion, we can always transform the data. Let us take an example. If any of the website or any of the application is creating semi-structured data, maybe JSON. JSON is a semi-structured data, basically. Now, Kafka will be consuming the JSON files in a topic and will be pushing out. Now, Spark cluster will be consumer for Kafka. Kafka has nothing to do with transporting the data from here to there. No, it will transport actual JSON file to Spark cluster only. Now, the purpose of Spark cluster is, so Spark cluster is being spun up upon by Databricks. Databricks is a code or which is a source, is a basically application over which I can write this code for transformation in any of the languages, maybe PySpark or SQL or so. So what that code will be instructing is take the JSON file from Kafka. In my code, I'll explain it out that I'll write it out that my JSON file will be coming from a Kafka so and so cluster IP address. Also, I will be. So what my code will do? It will take the JSON file. Then I'll be saying in Databricks code itself to use Panda. Panda is a library for parsing the data itself. To use Panda and parse JSON file with following parameters. This is in my code itself. I was knowing that what sort of JSON structure is coming to me. As per those parameters, I'll be saying Panda to parse this JSON file and extract meaningful information. So what it will be doing, it will be extracting few of the components from the JSON file itself by parsing it. And then those components will be pushed onto in my code itself. In Spark itself, I will be writing push those data points in data frame. Data frame is nothing but a relational data.
Transformation is going on, right?
Yeah,
All of this is under transformation. Parsing
this
of
is
the
basically
data.
transformation. Kafka is not doing nothing. Kafka is doing nothing here. Actual thing is being done by Spark cluster. The transformation is going on over here. So what here we are saying that change parse the JSON file, extract the data points or the actual data, and then push it into the data frame. So yesterday itself, I told you that data frame is an intermediate data structure itself used in Fargate. So in data frame is nothing but a relational database with rows and columns. So it will be translating that data into tables. So then afterwards, the actual JSON semi-structured data is now converted into structured data, transformed into structured data. And now this particular table will be pushed onto some data base or data warehouse as per the use case. Now I got a IoT data, maybe IoT or log. Basically, logs are unstructured. In the similar fashion, Spark can do the transformation of unstructured data into structured one also. All will be the beauty of the code. Whatsoever was written by the ETL specialist. ETL specialist is data engineer. He is responsible to write the codes here. So he can transform any sort of data structure to any other. Like he will be taking the logs itself, or he will be taking the images itself. This is what happens in Instagram when we'll be pushing images or when we'll be doing some sort of video calls, or if in any case we want to store that particular thing into some for meaningful information or so, they will use Spark or transformation to change that unstructured data into a structured form. And we will then be saving it into maybe Cassandra cluster. Cassandra is a database, no SQL database. What can store a large amount of images in structured form. So this is how actually the things go on. Now you understood that what Kafka is. Kafka is just a queue need to transport the systems. But the actual problem is by for handling large amounts of data, we can always lose some data, and Kafka ensures that none of the data is safe. Actual things done by Spark clusters to transform the things, and afterwards the transformation we can store that data anywhere in data warehouse or database. Maybe if we want it for BI or business intelligence or analysis, we will be storing it into data warehouse. If we want that particular thing for transactions, we will be storing it into some database depending upon the use case. Okay. Now, I believe you people understood. Okay, where it is used, fine. Take the analogy of YouTube website also, or any other website whatsoever is creating logs. Website tracking is one of the use case over here. What happens? We website is creating a log. We are analyzing that log. We are transporting that log to some transformation system like Spark. It is converting it into a structured sort of data, meaningful information. Then it is storing it out, and afterwards that database is being again used by that website to show me suggestions. That now, if you are matching this particular genre, you will be shown the similar genre movies.
Yes, sir.
And we can always consume that data set, may it be database or data warehouse, to train the models, to train the artificial intelligence models. So, in the backdrop, by using the signed privacy policies by we the people, actually the organization, bigger organizations are using our data, may it be our activities or may it be our behavioral patterns, to train their supermodels, and we
Yes,
are
sir.
not aware.
Insta
Actually,
did this thing that it shows people who watch this also watch these. Also in YouTube, like people like you may like it. So this is all done by this.
exactly. And this is very dangerous itself if I'll be showing you the actual use case of itself, that how they are logging our data, may it be web surfing, how they are consuming that data, and then in turn labeling that data, and then are training their models to have a super model, or you can say artificial general intelligence. Any of you know what AGI is? What is artificial general intelligence?
Sir, AI which could actually comprehend stuff as humans do.
Yes, what humans can do. In nutshell, AI capable of training its again on AI. AI what can generate other machine learning models also. So intelligent enough like humans. What humans can do, it can comprehend exactly what I can think of, AI can think of. So as we are discussing itself in the first place, what are the various use cases of these things? Now coming on to from here to AGI and on to the things that what are the supermodels and how can we gain the predictive intelligence? How AI can have the superhuman sort of capabilities. You know, basically, we have a saying itself: the more old a person gets, the more mature and knowledgeable he gets. So he will have you can say, bit of uh, capability will come into him to predict the things. Normally, if something happens to some child in our households, we normally go to the grandparents itself and they'll take their suggestion. That's what to do or what not to. Why is this so? Any of you? If you can explain why we go to the elderly people to have the suggestions. Reason?
They might have already seen or heard someone who would have undergone the similar things or the
Yes,
patterns. So
exactly. Exactly. The thing is, how humans gain the intelligence is by observing. We normally in our normal free time also, our brain is trained like this that we observe the thing. We get that particular knowledge stored somewhere in our back of the mind, or you can say subconscious itself. And that particular knowledge, what we are gaining throughout of our lives, will help us to predict the future in the later stages of life. So at any point in time, what we do is we observe the things around us. We see what if such are the inputs and these are the outputs of that particular thing. This is our observation. So normally the whole mankind, what I can say, the universe is working on a backdrop, what we can say patterns. There are some patterns being followed in the universe. So those patterns are static in nature. They are repeated normally. So same is the case with human behavior. Human behavior is also a in larger perspective, if you will see now, mankind or actual human behavior is predictable. And if we have a lot of data about those particular behaviors, and we'll having the you can say the data of billions of people with us with their behavioral pattern, then we can always create the patterns on that, and a predictive nature can be produced, or we can say predictive nature can be formulated over there. What happens for actual elderly people is they have got those knowledge base or the information seen over the time of their 80 years or 70 years, and they have got a you can say they have mapped the predictive behavior of most of the people what stumbled upon in their life. Maybe they'll be interacting with, may it be million people in their whole lifetime. So they have the knowledge base of predictions over million people. What if we have a similar model? What is being fed upon with the human behavior data of billions of people, or we can say all the peoples available in this universe? If we'll be feeding that particular data, and that machine learning supermodel will be capable enough of extracting the knowledge and being creating a behavioral pattern of them, then it will surely be able to predict the things with a very high, you can say, predictive ratio. Maybe it will predict with the accuracy of 90% or so, or 95% or so. So if we will be able to feed that much data to the system, so then we will be having a super model, we can say AGI with predictive nature. So what it can predict anything. If it will be fed with a video or live video maybe of two people quarreling and having a you can say talk over something, then it will be predicting what in next 1 hour they are going to do. Will they be solving the issue? Will the issue be more worse itself? Or you can say exact prediction of the future up to 95% that can be reached. So this is if done, and the key to all the training of such models, writing such models is not difficult because that is simple mathematics people have. Key is data to train such models, and that data is coming from our behavioral analysis by our website surfing, by our own IoT devices which are connected to internet. You have always heard of smart cameras being used on road junctions, smart cameras being used by people in their home itself, which are cloud connected. The smart cameras are feeding the video to the cloud itself, either by saying that we'll give you predictions, we'll give you not prediction, we'll give you notifications of motion itself also, or we'll be giving you X or Y or Z sort of thing. So in one way or other, they are grabbing your personal video feeds over to the cloud. Then those particular video feeds are being submitted to already trained models to have the face recognition, I can say, face identification, I can say, so that they label those videos, that particular unstructured data, because video feed is the unstructured data, is being converted into structured data by processing using the already trained recognition models or human behavioral pattern models or anything. And that particular
Sir,
labeled structured data, yes,
sir, I had a question over here. Like, we have every one of us has an Aadhaar card. So, does a
hmm,
UIDI is a UIDI a centralized database which actually connects to the AI servers and the sort of stuff which DRDO is doing these days? Like, we are testing AI softwares and facial recognition techniques on the lines of Chinese and Israeli firms. Like, is that
actually the thing is the Aadhaar is having our face also. Aadhaar, when one applying for Aadhaar card, it is giving us Aadhaar number, but it will be having our biometrics as well as face. So always that particular face identification, face recognition can be fed into the DRDO system. Software can be able to train the models, and those databases are then matched. Aadhaar database from UIDAI needs to be matched to the mapped face or even identified face to get the all the information about that person for law enforcement agencies also. It is possible, and I believe it is going on. You are speaking on mute, Kapni. You are speaking on mute.
I
Yes.
guess he didn't.
You have something to say? Actually, you are
like
speaking
someone
on
muted
mute.
me? Someone muted me all of a sudden. No, not an issue. So, sir, how predictive could the AI possibly be? Because, like, we know, like, many of the people who have their Aadhaar cards got their Aadhaar cards like a decade back, and their facial features must have changed over these 10 years or so. So, how predictive would the AI possibly be?
So
Uh,
these days, basically, now the Aadhaar system is saying you can update your facial recognition also. So what they'll do now, they'll have some sort of barrier itself, so that that will make the people uh, to let us say take an example, to take some sort of benefit from government scheme. They'll make it mandatory that we only want to get your face recognized. May it be for government employees, they want the attendance not by fingerprint, by your facial recognition. And in J&K also, they have launched an application for government employees to have their attendance by face recognition. Okay. So if this will be meant mandatory, automatically all of the people need to have their updated facial recognition over there. That will make the purpose fulfilled.
understood, sir.
This is how actually the government works.
Cameras installed in public sectors, which can be
Yeah,
accessed through some IPs. Like I remember seeing public cameras, we just have to enter their IPs and we can just watch it on our browsers. So
yes,
if it is publicly available, so the faces that are recorded in it can also be generated as an image and can be used to manipulate the data and store it somewhere.
exactly, exactly. The possibilities are endless. What I
Endless.
am saying, what I am saying, here you are viewing a very small subset of cameras which are available publicly, but the data sets to train the supermodels for behavioral patterns, also what I was talking of is needs to be large enough, comprising of billions of people's data to have the most accuracy in the model. So what they are doing itself, or what they will be doing itself, is they will be consuming the food feeds. May it be the Hikvision, Chinese government initiative, Cameras are basically made by Hikvision, and the cloud is being provisioned over there in China itself. They are taking the video feeds over there to China itself of years. They can use that particular video feed for anything. So what they are doing, they are not basically targeting a single individual. Collectively, they are taking the video feed, labeling that video with the identifiable information, like this is a human being, and the human being's name is Prakhar Khare or X or anything whatsoever here tag. So over the period of 3 years, the same video feed is coming to them. They have got a hell a lot of data about Prakhar. That in morning Prakhar, if that particular
Passes
camera
by
is in
this
your home itself,
place.
at
Yeah.
this point in time, at 7 a.m. he wakes up. At 7:30 he brushes the teeth. After 9 he will be going to office. At 6 he come back, and they'll also analyze the audio feed along with the video. Prakhar is saying this to his mom, Prakhar is saying this to his father, and their talks goes like that. And talks is about India government, about the elections.
Yeah, he is
Always
rightist
we
or
can,
leftist. They can
yeah.
always just.
So all this sort of data can be extracted from just video and audio feed or a single IoT device. And
Yes, sir.
when again this extracted data is being fed upon, now this is extraction of the data by using AI models. Okay. Now this all extracted data set individual will be fed upon onto a super model or AGI model, artificial general intelligence model. The data of the billions of such peoples is being fed onto AGI. Then AGI, like an old person, elderly person, will be fed upon with the hell a lot of data, and his prediction capabilities will be like 95%. So it will be saying Prakhar is going to maybe vote for X party in the upcoming elections, and it will be 95 to 98%.
Sure, sure.
Or
Uh,
it can predict.
just
Yeah, yeah, yeah.
just the other day, yesterday, not the other day, I read this article where a US woman consulted 13 doctors for her 5-year-old son in the past 3 years, and none of them were able to pinpoint the exact disease that he was going through, the disorder or the disease. But over a week of her searches on premium chat GPT, it
Mhm.
was able to figure out the infant's or the child's problem, like the particular problem, and then the doctors acted upon it, and he just got cured. Like it
So
was the
this is
chat
what,
GPT model. Like it, I
yeah.
don't know, like the data from biology textbooks,
Well,
the on.
basically, not only biology textbooks, all the data from the journals, all the data from the which is being fed up upon the international journals by the reputed doctors itself about a
Yes, sir.
particular disease case, use case, disease case. If they will be consulting to a single doctor, the knowledge set of single doctor, a person is not capable of gaining a lot of knowledge in his whole lifetime. It is basically understood. Now, ChatGPT is being fed by up onto the data of the numerous amount of top doctors of that particular trade. May it be by using their white papers, may it be by using their journals, may it be by using their disease cause history. Normally, the doctors of bigger institutes, they document their disease, the diseases what they normally what we say predict, not predict, what they cure of the uh, of the patients itself. They document the things, and those documents are being published somewhere, and those published documents are being fed into ChatGPT or such supermodels. So it will be having the knowledge base of millions of doctors worldwide. How can it not be predicting the things in a good fashion? This is a use case basically. Okay. So what I was talking of is use cases AGI, supermodels, and for having trained all these things, we need such sort of data engineers to actually handle the big data. So because if we not be able to handle the big data, how can we use that big data for useful information extraction itself? Okay,
Yes, sir.
so this is basically where the technologies like Kafka is not a big technology, but is very important to handle big data. Where Spark comes into picture, where IoT streaming devices, where larger data factory, data bricks, all these technologies. When all these technologies club upon, then only we can have a bigger, you can say, solution, or we can create some new technology. All these are small pivots or small parts of a big, larger picture. Now you understood how all these are being used to actually train a AGI. Okay. I told you about behavioral mapping, patterns, predictions, how the things go on. I told you what human intelligence is, what artificial intelligence is. Now, that is fine. Should we go towards, because yesterday itself I told you about load balancers. We'll be covering load balancers also. It is a bit no different topic itself. So, should we start with load balancers also?
Like, how much time would it take?
It is basically I will be walking you through the network load balancers what will be spun upon you can say the on-premise systems, and HA proxy is basically a package or needs to be installed on the Linux machines to use as load balancers. So I'll be showing you in very basic 5-10 minutes that what actually load. I believe you all know what load balancer is. What is its use case? When load balancer is used. So anyhow, I'll be telling you what actually load balancer is, what is the use case, what are the different components of the load balancer, what is HA proxy. If for practical purpose today you want to install it on your Linux machines, you can always follow a document to install load balancer and then configure it out. Configure the load balancer to serve various instances or IP addresses. Okay. Afterwards, we can always discuss of what ALB application. This is a bit, you can say, bigger topic, which is application load balancer on cloud, as well as then what are the target groups, what are the different cloud instances we can target upon by load balancer, what are listeners, what are deployments, blue-green deployments, as well as then we can always talk of weighted target groups. That how in actual the organization leverage to shift their base architecture, or you can say base platform from VM based application serving to platform based application serving or serverless itself. So how blue green actually works. So it is a bit larger topic. What I can say, if we'll be going into depth, it may take 1 hour or 1.5 hours also.
So we can always go through, like, revise the topics that we've covered in the past 2 days, today and yesterday's
Yes.
session, and we can start LB and ALB tomorrow. And also the
Yeah.
task documentation things we can complete today. Those who are left with
Yeah,
it.
that will also be fine. That will also be because just interrupt me itself because am not aware that how much you are gaining or so. I go with my pace and may it not match your pace itself. So just interrupt me whenever you will be feeling now that today we are going more hectic enough or the things are being overburdened or so. Just break me out because I have. One more thing to clear you out. I have much of the problem. I have very short term memory. I have short term memory. That is why I normally write out the things onto the so that normally at some point in time I normally go blank. While talking, I go blank itself what I was talking about, what is the whole topic was about, and why I'm here. Up till this, you can say this is an issue with me. And to because I know this issue, that is why I started making notes. Normally, when I talk to the leaders or when I am in meeting itself, I have habit of writing the things out, may it be in shorthand also, so that I'll not see, while speaking I am out of words. Actually, this is a problem with me. So everyone has his own positives as well as negatives. I know my negatives. I worked upon them, and I am sustaining in the industry. So may it be you have your positives and negatives. Just show your negatives to others so that others can work on. I am not hesitant to show my negatives to my seniors, my leadership, or anyone. So if I'll be hiding those now, then it will be problematic. Other people will be saying he is not working. I had told him to do such and such things, but he had not responded. But if he'll be knowing that now I am having a short-term memory loss, then he'll be all the people normally they write to me on the text itself. They give a brief intro of what I need to do. Apart from calling and speaking, they just put the thing into the chat box itself. So when I'll be reading that chat, I'll be remembering that yes, this is the task. Okay. So that is why I was yesterday also speaking to you people that write the things on chat box for my favor itself. Because
Yes, sir.
the things I speak, I follow. So in the similar fashion, if you people have some of the weaknesses, just expose them, talk to the team, talk to the other person, so that others will be well aware and they will take the corrective actions over. Whole thing is teamwork. Few members are very best at something and very worst at some other things. Take the best of someone, explore that, and then train it out. Okay, fine.
And so we can have this exercise again where you asked everyone to put down the topics that we covered on day one. So we can do it for yesterday's and today's as well.
Yes,
Because
that is very good. Yeah, yeah.
yeah,
Yes,
I
yes.
saw that somebody mentioned some topic in like for example in Deepak and Yash's, four of them coincided, one was unique in each. So reading
Mhm.
those, like we always can come back to just
Refresh out of
do,
your mind.
yeah,
That
refresh out and do our homework again. Yes,
yeah,
that this topic was also there.
this particular practice you can always do every day. Just follow this practice if you can. Like whatsoever will be learning, just put it on chat for your sake also, for my sake also, so that I may not forget that this particular topic is covered. And you have seen that I must have repeated some things more than one time. This is because of me.
Yes, sir.
Because I forget that whether I had delivered that or not. While refreshing my mind, while reading on those chats, it will be helpful for me also. Okay. For now, thank you. Any of the questions from you people? Anything? So today you will be completing the yesterday's task itself by creating the document or so. And tomorrow we'll be covering load balancers and all. And if the time will permit tomorrow, after all the load balancers on, we will be covering Active Directory also, basics of Active Directory. Okay. Though I was being told by the seniors and leadership itself not to cover Active Directory, but if tomorrow time will permit, just we'll be having the basic understanding of Active Directory, what
sir.
Active Directory is. So it will not be an alien thing for us as an engineer. So we'll be covering that particular thing also. Okay. So today
Yes,
you
sir.
do the yesterday's task with her, and tomorrow you will be doing the task of installing HA proxy after the HA proxy and load balancer session. Just go through that in the meantime tomorrow also. That how to install HA proxy on Linux, how to create some sort of targets, and that will be tomorrow. Right?
Okay, sir.
Okay. Thank you all.
Thank you,
Thank you
sir.
very much.
Sir.
What is the data about the
Hello.
This was